Hello, everyone, and welcome to our webinar, How to Build the Next Generation Data Lake, Interconnected Data Pools in a Multi-Cloud Environment. My name is Cristina. I'm the product manager in charge of Lentiq EdgeLake, and I will be hosting today's presentation. I'm very excited to have you all on board with me today. To review my agenda, I want to kick off with some context around data lakes and have a look at why current data lake architectures are failing to meet their goals. Next, we will look briefly at some common data lake patterns and their challenges, and we are going to take a look inside our interconnected data pools architecture, its advantages, technical details, and we are going to end with a short demo of Lentiq EdgeLake. Don't forget, if you have any sort of questions during the webinar, post them in the Q&A section, and we are going to respond to all of them. Before we jump in, I would like to introduce Lentiq and to offer you a context of this webinar. Lentiq is a spin-off from BigStep, a big data and bare metal cloud provider that has a lot of experience in handling large enterprise data lakes. Lentiq represents the big data business of BigStep and is built around the customer feedback and the experience we have collected over the years. Let's find out more about data lakes. The term data lake can mean a lot of things to many people, but they were initially designed to be large repositories of data that ensured no information got lost. Depending on the complexity of the business and the use case, data lakes might look slightly different from one another. However, they have some common traits such as storing, processing, and analyzing data. With this basic understanding of the data lake in mind, let's take a look at some classic implementations. First, we have Hadoop-based implementations. According to the model of the data lake defined previously, we have a couple of data sources. We have the data management layer, and we also have the data lake where the rest of the magic happens, and a wide array of business users that are interacting directly or indirectly with our data lake. In this type of architecture, the management layer is implemented with HDFS and YARN, and the entire setup is under the strict administration of the central IT department. They are responsible of maintaining this entire system and provide internal SLAs to the rest of the users. This type of implementation is very commonly found in on-premises environments. The data lake has to empower specific actions, such as ingesting, storing data, processing data, serving data to other layers, modeling it, and visualizing it. On top of the data, as you can see, we have to ensure there are a wide variety of data consumption tools that are destined to be used by each different type of user there is in the organization. At first glance, this architecture seems to be perfect for a data lake project. However, there are some particular challenges when implementing them. Complexity is due to the fact that the data lake has to support all data, all users, and all business cases alongside their associated workloads while delivering a high degree of performance. The briefness of the Hadoop-based data lake, which makes the setup unpredictable, is another challenge of this entire setup. And the need of having a highly technical Hadoop operations team that is able to maintain this complicated system on premises is another one. Another challenge would be the difficulty in auto-scaling, since everything is built from scratch and there are no management services in place. Secondly, we have data lakes that are implemented in the cloud using the cloud provider specific services. These data lakes run in a single cloud and are serving the same business requirements of the first category of data lakes. Even though services look similar to one another from one cloud to the next, they are implemented differently behind the scenes, are very tightly connected into their ecosystem, and workloads built to use them are not portable. In addition, this entire architecture requires a highly specialized cloud operations team that is able to design, implement, and maintain this entire system. One advantage of building a cloud-based data lake as opposed to a Hadoop-based one is that it offers a higher degree of scalability compared to the on-premises data lakes, but vendor lock-in, dedicated operations teams, and the difficulty to manage multiple teams in multiple regions makes them challenging to implement. These are the main two approaches that are being used today when implementing data lakes with production use cases in mind. However, let's take a look at some numbers. We can see that the rate of successful data lake projects is alarmingly small, and this drives us to ask ourselves if the current data lake architecture is the answer to today's challenges. Hadoop might have been the answer 5 years ago, but it isn't anymore. From our observations, it seems like a lot of centralized data lakes are having problems derived from the architecture and design choices made at the beginning of the project, since it was not built with a use case in mind. Overcentralization means that the data lake lacks flexibility and agility. Overgeneralization makes it difficult to adapt to a specific use case. Complex means they are over-engineered to be the answer to all problems, and they are very expensive since there is a lot of time and effort invested in engineering the environment. All these problems raise some warning flags regarding the current approach. We have also conducted extensive user research, and some of our customers complain about issues with data, like the data ingestion process, with implementing local projects, or managing a distributed data lake. These are extremely aching problems that caused major delays in their advanced analytics endeavors, and we have identified that companies are looking into ways to provide more flexibility and innovation space to each business unit. We are prepared to support businesses in building a decentralized data lake that will do just that. A radically different approach and architecture is needed in order to make data lake projects successful. Our main goal is to find the sweet spot and the right balance between flexibility at the data pool level and governance at the data lake level. We are extremely confident our product can deliver on this promise through our unique interconnected data pools architecture and the unique publish-subscribe mechanism that applies to data, code, and knowledge. Our data pools are completely independent, decentralized, can run on different cloud providers, providing companies with an agile and focused environment that can foster innovation. One of the use cases that is embracing the decentralized approach of building a data lake appears in the automotive industry. We have a customer that performs predictive maintenance for fleets, and in their use case, there are a lot of sensors that are generating large volumes of data in real time. In order to be able to respond as fast as possible to inputs, they need local teams that are deploying data pools in regions closer to the source of data and that are performing an initial data aggregation. There is also another central team that is developing engine models that are then used by the prediction team for predicting the next component failure. Since data pools are designed to serve a particular use case and are completely decentralized, enables our customer to quickly adapt to local needs and be more efficient. When data is aggregated, it is curated and shared with the rest of the teams, and our customer is present worldwide, which means that the ability to replicate and instantiate remote data pools quickly and manage them seamlessly are very important characteristics that are supported by the EdgeLake approach. As we have seen, current architectures have their flaws and were not built for the types of data that we want to store and the types of analysis that we want to perform. The EdgeLake is a data lake service that offers data teams the tools, collaboration mechanisms, and the freedom they need to innovate. We achieve all of this through a unified management interface that is able to seamlessly control all components and to offer a unified experience regardless of the underlying cloud provider. This reduces the learning curve for a team working with a new cloud provider and maximizes the data team's productivity. Our data pools are completely self-service, can be customized with the right technology stack for the use case, are liberated from strict governance rules, are agile, and can be operated by the data team alone without requiring a dedicated operations team. Since EdgeLake is offered as a service and requires such low maintenance resources, the cost of the data lake is dropping. Now that we know some of the most important advantages of EdgeLake, let's take a look behind the hood. The EdgeLake architecture is decentralized, distributed with storage decoupled from compute to achieve scalability and allow full on-demand consumption model. The EdgeLake is comprised of multiple data pools that can be distributed across multiple cloud providers in multiple regions. Currently, we are supporting Google and AWS, and we are preparing to launch support for Azure, on-premises, and Alibaba. Being a data lake at the core, the EdgeLake performs data and metadata management, manages your application stack, and also exposes a workflow manager that is going to be released very soon. Since we are using the widely popular Kubernetes technology and the object storage in order to be very scalable, cloud native, and ensure scalability. In our vision, Kubernetes is going to power the next generation data lakes and will be the de facto platform for AI and machine learning workloads, which means the data lake is future-proofed. Our management interface fully controls the infrastructure layer. For each data pool, a Kubernetes cluster is provisioned in the selected cloud provider and region, alongside with object storage buckets for each project that runs in that data pool. In terms of security, we are controlling access to these data pool and projects through a firewall management system, a permissions management system, and an authentication layer that we have developed fully in-house. Once deployed, a data pool can be scaled up and down at any point in time, and the process is instantaneous. The goal is to reduce infrastructure costs and increase the resource utilization rates. In the next releases, we are going to add auto-scaling mechanisms so that we are offering you peace of mind as well. Data pools, on the other hand, represent isolated compute environments that communicate with the rest of the data pool at data and code level. The platform is designed to fight data, applications, and code gravity by enabling users to write portable code that can run on any cloud provider at any time, making your business multi-cloud ready. Data pools are designed to wrap around a particular use case and available skill sets, so the application distribution can be customized. It is also closer to where data gets generated, which enables faster and more affordable data processing. From an applications perspective, we are offering a catalog of applications that are dynamically finely tuned based on the resources configured by the user. We have focused on open source technologies so far to help users get started instantly with their projects, and scaling and access is fully controlled from our management interface. Our publish subscribe mechanism enables less oppressive governance, which in turn makes the EdgeLake a happier place for your data team. Through this concept, we can share data between multiple data pools. Individuals can subscribe for updates related to a specific dataset and get informed when new data is available or when metadata information is changed. The concept of publishing and subscribing to data is implemented to code as well to help companies build an internal knowledge repository, ease collaboration between data scientists and data teams, and increase their efficiency. In our future releases, we are also going to include a module that can turn notebooks into portable containers that could be executed as part of a workflow. We believe this approach is a true game changer for data teams that have troubles productifying their work either due to the lack of skills or the friction with the IT department. You might ask yourself, how can agility and self-service be achieved if you're also enforcing rules to make the data lake a fully governed environment? Usually, if you want agility, you have to give up control and vice versa. In our vision, it doesn't have to be all or nothing, and we truly believe we have found a sweet spot in helping users balance flexibility and governance. I can get into more details if you want at the end of the presentation of how the system works behind the scenes. So I think this is the presentation. Let me switch over to the product itself and give you a very quick demo. Okay, let me prepare the correct dashboard. So here we have the Lentiq EdgeLake interface. This interface is the management interface that each of your users is going to interact with. We have multiple data pools, and you can easily create a data pool. I can show you at the end of the presentation how simple it is. And in each data pool that we are having, we can have multiple projects. In each data lake, we can have one or multiple data pools, so the data lake itself can scale indefinitely. Let's take a look at the data pool settings. For the first time, we have to configure the number of servers and their configurations. So basically, these servers are behind the scenes of the Kubernetes cluster, and they are supporting all your projects that are deployed in this data pool. Here we have the distribution of resources for each project, and these are quotas, management quotas that you can use for budgeting your internal projects. We have a list of projects that we have configured, a list of firewall rules that apply to the entire data pool, and we also provide a possibility to add more granular firewall rules for project or for a particular application. And you can also extend the management user base by adding your users here. And basically, a manager will be able to increase the resources of the data pool when needed. A data pool can have one or multiple projects. Each project is represented by some resource quotas. Basically, these quotas are used for the applications that are provisioned in this project and can be modified when resource demands are increasing. We can add users with management access on the project or with access only to the applications, and also firewall rules that are more granular. For the applications part, we are supporting currently Spark, which is a very popular big data processing engine, PostgreSQL, a relational database, StreamSets, which is a nice tool for ingesting data and do some pre-processing, Jupyter, which is the default IDE for data scientists and data engineers, and that can be connected very quickly with Spark clusters, SFTP proxy, which helps us upload data very easily into the data pool, and of course Kafka for real-time streaming, and Spark SQL that enables you to connect remote BI tools to our table browser that I'm going to present later. So basically, these applications are the basis of our system, and in the future, you could add your own applications. All of these applications are running on Docker containers, which means that they are highly scalable. For the application part, we can easily connect to them through the connection screen, and we can configure at any point in time the resources and the number of containers that are associated to a particular role within the application, and as well some firewall rules. The data management system is the one that is very special. We have a file browser. So for each project that we have deployed into our infrastructure, we have an object storage bucket that is running behind the scenes and is associated to this project alone. So if we are going to change or switch the project, we can see that in the file browser, there is no data. And this will be the screen that appears to users that are not having the rights to see the project itself. So your data is secured only for it to be accessed by the users you allow to. Datasets files have some automatic completed metadata information like file size, last modified, file path, and so on. But we are also offering the possibility to add data documentation through a small code, and of course attach files that are related to that specific file. For example, if you are using this CSV file for a particular Jupyter notebook, you can attach the notebook and connect the knowledge you have extracted from that file to the file itself. What is more interesting is that you can publish this dataset, this file as a dataset, and publishing it is very, very simple. So basically, I'm just creating a name for my dataset. I'm going to type some description. I'm going to add some tags, customers, the format of the file, and the visibility. The tags are going to help us with data discoverability inside the data lake. So basically, when we are publishing a dataset, the dataset is going to be available in all projects that are part of that data lake. So other users that are logged in a different project are going to see this dataset that I have published right now, and they could subscribe to it if they want to. This process takes a little while. Available datasets. As you can see, the dataset that I have added is already present here, and we can subscribe to it very, very easily. When we are subscribing to a particular dataset, the dataset, we are going to be notified when metadata information is changed, or when the data itself changes, and we are going to receive this notification via the email. If we want to unsubscribe, we can do that at any point in time. When we are trying to use this particular dataset, we can copy it to our project. And since I have access only to the second project with the user that I'm logged in, I'm going to copy it here. And afterwards, I can use it for further analysis and data exploration. Let's move back to the first screen. So this is how the data and metadata management system works for the file. For the files, we are going to go back through the tables later on. Let me switch back to the applications. So we are going to connect to a Jupyter notebook. Jupyter notebooks can also be shared with the rest of the organization, with the rest of the data lake, through this curated notebooks tab. So basically, each time I'm entering a Jupyter notebook, I can simply publish it, and it is going to be available to the rest of the guys. We are performing this type of operations to make sure that we are sharing data preparation best practices or different models that we have worked on, and so on, so that this curated notebooks tab becomes your internal knowledge repository. And we think this is very cool to kickstart a local team that has never worked with data science before, for example. In the notebook itself, we can do multiple things. Let me run all the cells. So we can directly interact with data that is put into our object storage. Basically, we have client libraries that can be used like an HDFS CLI controller, and we can put data, we can download it, and so on. Then we can list all the files that we have in our particular data store. So you can see that in the file browser, I have a number of files that I can access from within the notebook itself. From the notebook, we can also connect very easily to a Spark application that we have developed beforehand. We are using the internal URL to connect to the Spark application, and we will do this. Actually, I have the application running. I just have to refresh this. So as you can see, the application has already registered into the Spark master. And now we can use the Spark to access data that is stored into the object storage. So basically, we can see what data we have uploaded, and we can also transform that data. Okay, I think I transform that data into a pandas data frame and apply some specific operations on top of it. What is more interesting is that we can use that data frame and save a table from that data frame. And this table is going to be a persistent table that can be then used by external BI connections tools like Tableau or Looker or ClickView. And you can do further analysis with your business analysts on top of that dataset. So once we have run this cell, we are going to see that the table gets populated in the table browser. The table browser itself has a little information about where the files corresponding to that table are stored. Basically, here we are going to have files that are stored in Parquet format. And we can look further into how the data set is structured. We can see a sample of the data and the columns that are attached to that table. We can add a description for the table itself. We can also attach files, such as notebooks that are using this table browser or advanced metadata information that informs the users how the table was created and what is its purpose. And we can also tag and describe each column from the table. This can help us flag personally identifiable information. It can help us better understand our tables, and of course browse through them much more easily. I think with that we are about to get done. I think we have some time for some questions. Before moving into that, let me recap a few of the Lentiq EdgeLake principal features. So as you can see, we have data and knowledge sharing, data and data management. We can perform data science at scale. We are supporting a number of very highly specific applications, and we also have support for Ray and Dusk if you want to scale your data science workloads. And we are inviting you to test the product and share your feedback with us. So let's move on to the Q&A session. So the first question is, can data be moved between different cloud providers? Well, this is happening by default because through that management system that we are integrating, let me go back to this. So basically we have management system that we have developed in-house. Basically, it is an abstraction layer of the underlying object storage. So data in the data pool is going to be prefixed with BD//. And when the user wants to share data from project 1 to project 4, regardless of the underlying cloud provider, we are going to make the translation behind the scenes. And users are going to be able to copy data from one point to the next. And in the management interface, I can also show you how simple that is. So for example, once I subscribed to a particular data set, I can also copy it to my project. And this can happen between different cloud providers, different projects, different data pools. And everything is automatic. I can show you very quickly. Unfortunately, I do not have Tableau installed locally, but what you can do is provision very quickly a Spark SQL cluster. And this SQL cluster is going to expose the JDBC connector, and you are using that to connect from your local Tableau or ClickView or Looker system. This is going to take a few moments. Another question is, can other applications be executed on the platform? Currently, we are not offering support for that. We are working to include a generic application support. So basically, each data pool owner could create its own applications, and they could add those applications in our catalog. And those applications are going to be firstly present only in the data projects that are part of the data lake of the customer. And with that, we are going to further add support for applications providers if we see there is request for that. Will you be adding support for other languages like R? Actually, we can do that. Currently, we did not have a lot of requests around R, but it can certainly be done. Okay. To move back to the question about Spark SQL, here you have the JDBC connector link, and users can use that to connect to our Spark SQL interface and retrieve the data that is stored in the table browser. Well, I think the time has run up. You can test a product, and we are inviting you to do that. Thank you so much for your time. The testing period will be free, so if you are interested, just drop us an email, and we are going to make sure you have a data pool on hand. Looking forward to see you at the next webinars that we are going to host, and I wish you a wonderful day. Thank you.